Okay, so today we are going to study a very important data structure. This is going to be very handy, which can reduce the time complexities of many problems significantly just by adding a little bit on the space side. Okay, and this is called a hash map or a hash table. Okay, and the whole process is called hashing. In today's class, we are going to study some basics of hashing, how a hash table functions, and we'll also discuss some problems which have been asked in the interviews, and we'll see how you can solve these problems optimally using a hash map or hash table. Okay, I have a question for you guys. Have you ever encountered hashing in your real life? Hashing, have you ever faced any practical scenario where you have used hashing? Let's talk about those days when there was no corona, or let's call it the pre-COVID era. Let's talk about the pre-COVID era. So during the pre-COVID era, we used to go out on holidays, right? We used to go for trekking. We used to go to visit different places, right? And whenever you go to a different place, you need to stay in a hotel, right? So let's say that if you go to a hotel and if you want to look for a room, right? You go to the receptionist and ask whether a room is free or not. Now the job of the receptionist is that he will take all your preferences. He will ask you what type of room you want, and then based on your preferences, he will just check whether a room of those preferences is free or not, right? So you go to a hotel, and in this hotel you have a receptionist, right? And you go to the receptionist and you ask for a room. Give me a room which, let's say, is a single bedded room, has a AC, has a balcony and all, right? And this guy will just check whether a room is free or not. Now this guy has got two ways to check the room. First is that he can actually go and he can visit all the rooms of the hotel and check whether such a room is present or not, right? He will go, he will knock each and every door, he will check whether the door is closed or whether the door is open, whether the key is with him or whether the key is with the person who has taken the room, right? So this is one way. Now, as all of you can see, that this is a very unoptimized way of finding a room, right? Because if there are, let's say, 200 rooms in this hotel, if this is a very big hotel, then he is going to check each and every room for each and every customer, right? So if there are n customers and if there are m rooms, then how many checks is he going to make? This unoptimized receptionist is going to make n into m checks. This is not going to be profitable for the hotel business. Whoever is the owner of the hotel, he will fire him the next day, right? The other way that this guy can use is he can maintain a map, right? He can just against each and every room, right? Let's say room number 101, 102. He can maintain whether this room is occupied or whether this room is empty, right? Or he can also have the keys in the key holder itself. He can also have the room number written, right? So now whether he has the key or not, that is also visible here. Whether the room is empty or not, that is also visible here. He can also have the type of the room written here. So he can have that 101 is a single bedroom which is empty. 102 is a single bedroom which is non-empty. Let's say 202 is a double bedroom which is empty, right? So he can have each and every information regarding the room stored against the room number. Okay, is this going to be a better choice? Yes, right? That is why each and every receptionist actually does this. You must not have seen any receptionist who actually go and check all the rooms, right? But this is something which you all must have seen, correct? Let's talk about another example. Okay, so let's say that in those days we also used to go to shopping malls, right? So this was an example when we want to stay on a hotel. Another example would be that if I want to go to a shopping mall. Okay, now if I want to go to a specific shop in the shopping mall, again there are two ways. That either I go and check each and every shop in that mall, right? So there are going to be multiple floors in that mall, right? Each floor will have different shops, right? And let's say I'm looking for a specific shop, okay? let's say I want to buy the magical drug Coronil. Okay, I have a perception. I have read on WhatsApp that if I take Coronil, then Corona is not going to catch me, right? So what I would want is I would want to search this shop which is selling this drug Coronil, right? Now again, I have got two ways to do this. First is that I go to each and every floor and I check each and every shop one by one, right? Or some of the malls who have a logical owner or who have a logical management, what they do is they put a board or a map of the mall, right? So what they do is they put shop number, they give the complete address of the shop, floor wise. They will say that in the first floor these are the shops which are there in this order, right? And in the second floor these are the shops. So what I can do is I can use this map and I can find the exact location of that shop, and then I can go to that shop, buy this drug, and then I can make sure that corona is not affecting. But since this was a knowledge that I gained from WhatsApp, this might not be true, right? But this way of searching the shop, this definitely is a better approach, right? Instead of visiting each and every shop, what I'm going to do is I'm going to check this map and then find the exact location of the shop. Okay, does this make sense to everyone? These are two examples which all of you must have used, like these or something like this in your real life, right? Where you have to keep track of things and you just create a table or you create some entries and you just mark true false, or you just the attendance register that we have, that we used to have in our school classes, right? That was also an example of hashing. If let's say a teacher wants to know whether a student is present in the class or not, right, what he will do is he will just do a linear scan on all the students, and doing this linear scan while taking the attendance, he also marks the attendance, right? So if there are students, let's say in our class we have Aman, then we have Monica, then we have Anmol, right? So if I have to check whether all of these guys are present in the class or not, what I can do is just before beginning the class, I can just mark their attendance, right? Now, if let's say after some time I want to know who all were present in the class, I will not do another scan. I will just check whether Monica is present, whether Aman was present or not, right? So this again is another example of hashing which we have been seeing from the school days, right? Okay. Is Oyo also used concept of hashing? Yes, Oyo must also have used this same concept, right? Okay, so this is the general idea of hashing. Now let us see how it actually functions in the world of computer science. Okay, so let's try to understand this whole process using an example. So let's say that we are given an array, and this is just to understand how hashing is going to function. Okay, this is going to be a very easy example to understand the working of hash maps and hash tables. Okay, so let's say that you are given an array, and in this array you have all the numbers from range 1 to 1000. So you know that any number in this array is going to be from, or let's say from 0 to 1000. Okay, so you're given an array of size n, and each and every number of this array ranges from 0 to 1000. Okay, you have to return the frequency of every number. Let's say you have got queries about the numbers. Okay, so you have this array and now you are getting multiple queries. You have to answer these queries, and each query asks you the frequency of a number. Okay, so for example, if the array is something like this, okay, if this is the array, after getting this array you will get different multiple queries, and you have to answer what is the frequency of the given number in that query. So for example, if your query has 58, you will return 1 because 58 occurs only single time. Then if let's say you get 3 in the query, then you will be returning 2 because 3 is occurring twice in this array. If you get 2, you will again be returning 2 because 2 again occurs twice in the array. Okay, is this scenario, is the problem clear? How can we solve each and every query in the most optimal time? Okay, let us start from the brute force. Okay, what is the brute force way to solve each and every query? the brute force way to solve each and every query is that whenever you get a number in the query, you iterate over this complete array and you count the occurrences of that number, right? So if I get 58, I will do an iteration over the complete array, which is going to be an order n operation, and then I will return 1. If I get 3, I will again do another order n operation over the complete array, and I will return 2. Okay. So what is the total time complexity of, if I go by this approach? Let's say there are q queries. Solving each query takes order n time. So the total time complexity is going to be q into n. Right? Now this q can be very, very large. Okay. So this is something which is not optimal, right? Any other approach that we can use in this case that you might have studied in the previous classes? Can we optimize this order n factor here? Let us say if I do some pre-processing, okay? If I sort the array, what happens to the order? Now the order is, the array sorted in ascending order, right? Now can I find the frequency in a more optimal time? Can I reduce this factor of n? Yes. Now how can we count the frequencies? Now we can use binary search. You must have studied this, you must have learned it in the previous sessions, that given a sorted array, you can count the number of occurrences of any element using binary search, right? You can just find what is the first occurrence of that number using the binary search. Then you can also find what is the last occurrence of the number, and then you can get the length of this subarray, right? So if you use binary search after sorting, then each and every query is going to take how much time? Only log n time, right? So now what is the total time complexity of finding all the frequencies? So if you have q queries, then solving all the queries is going to take you q into log base 2 n time. This much is the time that you will invest in resolving each and every query. But before this, you have also sorted the array, right? So that amount will also be counted. Now, whichever is the greater of these two will be the overall time complexity, right? This still is a lot, because again, n can be very large, q can also be very large, right? So can we further optimize this? Right. So as many of you have already suggested, what if I have another array, right? So I can see here, if I focus on the constant of the problem says that any array value is going to be in this range strictly, right? Any array value cannot be more than 1000 and it cannot be less than 0, right? What if I just have another array where each and every index of the array represent the numbers and the value in the array represents the frequency of a number in this original array? So what if I have another array and just call it a frequency array, right? And store and count the frequency of each and every original array element in this array, right? So I can have another, let's say, frequency array of size. What should be the size of this array? What should be the optimal size of my frequency array? If I know that all the numbers are going to be in the range from 0 to 1000, I know that the maximum number that I can have is 1000. To have 1000 as an index, I need an array of size 1001, right? 1001. This array is going to be, this array can accommodate all the numbers from 0 to 1000 in index, right? So now what I will do is, whenever I am iterating over this array, so initially I initialize this complete 1000 sized array by 0. So in this array, initially I have 1000 zeros in every index, right? And then whenever I visit a number, I will just loop over this array. And whenever I visit a number, I will increase the value here, right? Because this denotes the frequency. So initially I am assuming that frequency of each and every number is 0. Whenever I encounter a number, I will increase the frequency, right? So I will just loop over this array. I will say for I equals to 0, I less than n, which is the size of the given array, I plus plus. And I will say frequency of a of I plus plus, right? If I just do this, what will I get? In this array, frequency of 1 will be increased to 1, right? And then frequency of 2 will also be increased, and it will be 2. Frequency of 3 will also be 2, and so on, right? So now, after I have built this array, if I have to return what is the frequency of any given number, right? What is the operation that I have to do? After I have built this array, for any number I, for any given number I, if I have to return what is the frequency, frequency is nothing but frequency of I. So if I have to return what is the frequency of 58, I will quickly do frequency 58. If I have to return what is the frequency of 2, that is going to be frequency of 2. And that's it, right? So what is the time complexity of this operation? Time complexity of this operation is constant, right? This is a constant time operation. I'm just retrieving a value from the array, right? So this is going to take order 1 time, correct? Now I have q queries, and each query is being solved in order 1 time, correct? So what is the overall time complexity of solving all these queries? Overall time complexity becomes order q, because each and every query is taking how much time? Only order 1 time, right? So this is the time to resolve each and every query. And then we have also built this array, right? So we have iterated over the given original array, and then we have also built that array. So this takes order n time. Order n plus q, whichever is greater will be the final time complexity. Okay. Does this make sense to everyone? How we have solved this, like optimize the time complexity from n square to n log n plus q log n to order n plus q. Okay. Now, one of you just asked what happens when array elements range from 1 to 1 raised to power 10 raised to power 18. Okay. What if, so in this problem, it was given to us that the numbers are going to range from 0 to 1000. That is the reason why we are able to create an array, right? I can create an array because I know that indexes can be in this range, correct? Now, what if the numbers are going to be very large? Okay, a of I, as asked by Lucky Movies, what if the range is this? Can I use the exact same approach? So now I cannot use the exact same technique, because I cannot have an array, I cannot create a frequency array which has a size 10 raised to power 18, right? Because this is going to cost me a lot of memory, right? How much memory is it going to cost? If this is an array of integers, one integer takes how much memory? 4 bytes, right? So if you want to create an array of size 10 raised to power 18, this is going to cost how much time? How much memory? 4 into 10 raised to power 18 bytes. Can anyone quickly tell me how much is this in GBs? 4 into 10 raised to power 18 bytes. How much is it in GBs? So if you want to create an array of that size, you need to have this much of memory. You need to have this much of memory in the RAM, right? So this much of memory in the RAM is definitely not going to be possible for an ordinary computer, right? So what we are going to do is, now we'll have to be a little more logical, and we'll have to apply a little more mind, right? Unlike Mumbai police. So let us be a little more logical, and let us try to see if we have an upper limit on the memory, right? If let us take a smaller example, and let's say that the numbers are ranging from, just to understand, let's take the smaller example that the numbers are again ranging from 1 to 1000, but the largest array that I can have a size of 100. This is the upper limit on the size of array. Okay, similar example. So what we are doing is, numbers are ranging from this 1 to 1000, but the maximum size of the array can only be 100. Right now, again, I cannot use the exact same method. Why? Because having an array of size 1000 is not possible, right? So if I want to store the numbers as an index in the array, then I can only store till 100. Is there a way using which I can map all these numbers from in this range from 0 to 99, because the maximum size that I can have is 100. So can I map all these numbers in this range? Is there a way? Have we seen any way? Or let's say that all these numbers are ranging from 0 to 1000, right? Yes, what can we do? We can simply take modulo, right? Is everyone familiar about what is a modulo operator? This gives you the remainder, right? So if I take modulo of any number ai with 100, which is the maximum size of the array that I can have, can I say that this number, which is ai modulo 100, will always lie in the range from 0 to 99? Can I say this? Yes, correct. So I have got one way to map these numbers which are in this range from 0 to 1000 to a range which is very, very small, right? This range has a length 1000, and now the resulting length is only 100. So I am mapping these 1000 numbers to 100 numbers. Okay. If this is the case, how am I going to store the numbers? Let's have an example. Let's say I have 492, 5, 8, 23, 15, 142, and some random numbers. Okay. And now if I can only afford an array of size 100, right? How can I map these numbers? I will first take the modulo of these numbers with 100. And then whatever number I get by doing this operation, I will store these numbers in that index. So I get the index by taking modulo of these numbers by 100. So first number will be stored against index 92. This will be stored against index 5. This will be against 23, 15, 42, 54, and 64, right? So if I have these as the array index, 54 and so on till 99, then at 0 is going to be empty, 1 is empty, 2 is empty. At 5, I am going to have 5. At 23, I will be having 823. At 42, I will be having 142, and then 654, 764, and so on, right? So now, is this going to work? Is this going to work correctly? If these are the indices and I keep the values in array element mod 100 index. Okay, now some of you are saying that this is going to work, but there can be collisions, right? What are collisions? Okay, so let us say that in the original array, I have these numbers 100, 201, then I have 302, then maybe 300, 401, 200, right? If I have these numbers, right? So in which index should a number belong? In index 0, how many numbers am I going to have? In index 0, I am going to have 100. Then I am also going to have 300, and I am also going to have 200, right? All these numbers will try to get inserted against a single index, right? These are called collisions when there are multiple prospects candidates for a single index, right? So index 1 will try to accommodate 201, then 401. Index 2 is going to have 302, and then 2 also, right? So there is no one-to-one mapping, right? A one-to-one mapping does not exist, correct? If a one-to-one mapping does not exist, is this even possible to use this technique? Are we going in the wrong direction? Is this a correct way? Is this the correct path that we are taking? Maybe, right? We have also studied a data structure called linked list, right? If you know about a linked list, what if we have an array of linked lists? If I keep an array of the linked list nodes, right? Can I say that this can work in that case, right? So currently, if you are only storing a single element, if you are only trying to store a single element against one index, then since there is no 1:1 mapping, this will definitely fail. We are going to lose some data, right? Because every time you have a collision, the previous number will be overwritten. But what if I use a linked list? So instead of having these integers, right? If at index 0, I have this complete linked list stored. So if I have to create an array of linked list, what do I need? I only need the pointer to the head stored in that correct index, right? only if I have an array like this where I have this head pointer, then using this head pointer we can have the complete linked list, right? So we don't need to actually store this complete linked list in the array. We only need to store the head pointer, right? Similarly, at index 1, we can have the head pointer of 201. At index 2, we can have the head pointer to 302. Does this make sense to everyone? So we can still manage doing hashing in this case. Even though the range which we have to store is very large, the size of the array is very small, but we are making sure using the modulus operation that we are mapping these numbers to the available size. And then using a linked list, we can also make sure that we are not losing out any data, and we are storing all these numbers using the chaining. Okay. Now, if I'm storing the values like this, now if I have to find what is the number of frequency, or let us say if I just want to check whether a number is present or not, right? What is the worst case time complexity of this case? If I'm going by this approach, if I'm storing linked list, if I'm having an array of linked list nodes, what is the worst case time complexity of finding whether a number is present in the array or not? Worst case is going to be if all the numbers are mapping to a single index, right? So if let us say that the numbers are these 1, then you have 401, then you have 101, then you have 601, right? 701 and 501, correct? If I take mod of all these numbers with 100, all of them are going to take the exact same key. So all of them are going to map against 1. So what will happen now? If I have to search whether a specific number is present in this array or not, I will be traversing this complete linked list, right? So first, let us say I get a query. I get a query of, let's say, 801. I have to check whether this number is present or not. So first of all, I will try to see in which index is this number is stored. So I will just do 801 mod 100, which is going to be 1. So I go to index 1 of my array. And now I have a linked list of size n. I will iterate over this linked list, and since this is also not in sorted order, right? I will have to check each and every element, and I will then figure out whether I have 801 or not, right? So this is going to be a order n time complexity operation. Does this make sense to everyone? This is the worst case time complexity of checking whether the number is present in this list or not, right? Okay, so this is the worst case. What could have been an ideal case? When can I say that this is the best thing that I want? What is the ideal case in this scenario? The ideal case would be that if all the numbers are mapping to different index, if all the numbers, if I have a data, and like if I have the data in such a way that all the numbers are distributed evenly amongst all the index, right? So if I, let's say, have 401 against 1, then I have 2. So let's say I have 702, and then I have 23. So I have 823, and I have exactly one element for each and every index. This is going to be the ideal case. And what is going to be the time complexity in this case of just finding whether a number is present or not? Since the list size in each and every case is exactly 1, the time complexity is going to be constant, right? So this is the best case time complexity, and this is the worst case time complexity. Is everyone clear about these two? Okay, great. So the aim is that the mapping function that we are using, right? Currently the mapping function is mod by the size of the array, right? So the aim should be that whichever mapping function we are using should try to evenly distribute the load amongst all the possible indices, right? So this function, the mapping function that we are using, this is called, what is it called? Anyone knows what is the name of this function? This is called the hash function. Okay, and hash function is a very, very big topic in itself. There is a lot of research going on. There has been a lot of research already done on what could be a better hash function or for what case, right? So you can just go and Google up and read about hash functions. There are multiple publications on these. You can read, you can go through some of the publications if you are interested, right? But taking a mod This is the most simple hash function that you can have, but not the most optimal. Right? This was just for the example. You have very complex, very optimally written hash functions which try to distribute the load evenly. Okay, so you can just go back and read about what are hash functions, and you can also read about some of the common hash functions. Okay, cool. Now, if I write one of the best hash function, even which is the best possible hash function currently present in this world, can I say that that hash function will guarantee zero collision? Can there be any hash function which can guarantee zero collisions? No way. Why? Why no? You have got a very big range of numbers, right? You have to map numbers from, let's say, 0 to 1000. You have got only 100 slots. Do you guys, are you aware about the pigeonhole principle? You have 100 slots and you have to put 1000 things. When you put the first 100 things, and if your hash function is guaranteeing zero collision, 100 slots are filled. Right now, when you pick the 101 index number, this is definitely going to collide with at least one of the pre-existing slots, right? So since you are mapping a bigger list of numbers to a smaller list, you will always have collision. So there cannot be any hash function which can guarantee zero collisions. Okay. However, there are hash functions which try to distribute the load evenly. That is possible. There has been a lot of research done on that. You can Google and read. Okay. Cool. So this is the basics of hashing, right? You can read about hash functions. You can also read about hash tables. Hash table is nothing but key and value, right? So you must have seen what is a dictionary. If you use Python, you must have used hash maps. So hash maps or hash tables, they are nothing but a key value pair. This key is the result that you get from the hash function. This is a hash code of any value, and in the value you can store anything, right? So the key, as you all now should understand, these keys in this case are the index from 0 to 100, right? So keys are always and always going to be unique. Values can repeat. You can store the values in list or maybe in some other data structure, but keys are always going to be unique. Okay. Now there was a question that if you are using a list, is there any specific reason of using a list, or can we have any other data structure here? What do you guys think? Can we have any other data structure in place of list? So Surit is asking why we use linked list. Is there any specific criteria? Correct. So Komal has got a good solution to that. If I'm using a list, what is the worst case time complexity of searching a list in if you have a list which is not sorted and which is a linear linked list, what is the worst case time complexity of searching in this list? Worst case time complexity of searching in list is order n. Okay. Now, do we know any data structure which provides a better searching time complexity? Is there any data structure which can store the numbers maybe in some order and then can give us a better time complexity? Do you guys know about binary search trees? In a binary search tree, all the values on the left subtree are going to be less than or equal to the value of the root. All the values of the right subtree are going to be greater than the value of the root, right? So just by using a technique like binary search, it can always discard, while searching for a number, it can always discard half of the search space, right? So what is going to be the time complexity to search a number? It's going to be log base 2n. If you are using Java 8, if any one of you who is using Java 8 must know this, that in Java 8, they optimize this worst case time complexity of retrieving from a hash map using a balanced binary search tree. In a normal binary search tree, in worst case, you can also have a time complexity of n if the tree is skewed. But if the tree is always balanced, then you are always going to have a searching time complexity of log base 2n. So in Java 8, what the hash map does it, if the size of the list is till a threshold number, which I don't remember correctly, I guess it's 5 or 6, Till then, it maintains a list. If the size exceeds the threshold value, then it converts the list to a balanced binary search tree. So the worst case time complexity that we have seen to be order n will reduce to order log n. Okay, cool. So guys, this is in brief about hash maps and how they work. Okay, let us quickly solve a problem also. Okay, in which type of questions can we blindly use hash functions? Okay, in any question where it talks about the frequency or counting the numbers or maybe checking whether a number is present or not, or checking the presence of anything, then you can use hash function, or then you can use hashing. Okay, let's quickly solve a problem and then you will get a better idea of when to use hashing. Okay, so the problem says that you are given an array and you have to check whether there exists a subarray which has sum equals to 0. Okay, so for example, if your array is this, in this case, does there exist such a subarray? Yes, right? If you see the sum of this subarray, what is the sum of this subarray? It is exactly 0. So you can return true. If there exists a subarray which has a sum equal to 0, the subarray can start from any index, it can end at any index, it can have any length which is possible. But if there exists any type of subarray which has sum equals to 0, then you can return true, else false. Okay. Modify cadence algorithm. Okay. How will you do that? Remember that the subarray can start from any point. This subarray is starting from this point. There might be an input where your subarray, which is causing a 0 sum, can be present, let's say here, or the subarray can be present here, or maybe the complete array can also be the subarray. What is the brute force way? If you are not getting any solution, can you quickly write down what is the brute force way? Okay, the brute force way is going to be that you actually try to calculate the sum of each and every possible subarray, right? So you first check all the subarrays of size 1, then you can check all the subarrays of size 2, then you can check all the subarrays of size 3, and so on, right? How many subarrays are possible? N square subarrays are possible. To calculate the sum, what is going to be the time complexity? For every subarray, you will also run another loop to calculate the sum. So it's going to be an n-cube solution, right? Which is highly unoptimized. How can we come up with an optimized approach? And we have also studied hashing. Hashing doesn't seem to contribute in this question, right? Okay, let us assume that there exists a subarray. Okay, there exists a subarray which has got sum equals to 0. Okay, so let us say this is the initial array that we have, and there is a subarray, let's say this part, which has a sum equals to 0. How do we define a subarray? We always define a subarray using a range of indices, right? Because as I said, the subarray can start at any point, it can end at any point, right? Let us say it starts at a point L and ends at an index R. And I'm saying that we are just assuming that the sum of this subarray starting from L to R is 0. Okay. Now, if this subarray has got sum equals to 0, right? If I also have the sum of all the subarrays starting from 0 stored with me, okay, what can we say about this part? This part which is in the blue dotted line. What is going to be the sum of this part? The sum of this part is nothing but sum from 0 to R, right? And this sum from 0 to R can be broken down as sum from the range 0 to L minus 1, right? Plus sum of the range from L to R. Does this make sense to everyone? Right? So sum of any subarray can actually be written in terms of this prefix sum, right? I can write sum from L to R is equal to sum from 0 to R minus sum from 0 to L minus 1 index. I can write the sum of any subarray which starts at index L, ends at index R, in the form of the sum of subarray starting from 0, which is nothing but the prefix sum. Everyone here understands what is a prefix sum, right? So if I have a prefix sum array P, then I can say that the sum of the subarray starting from and ending at R is nothing but P of R minus P of L minus 1. Does this make sense to everyone? Prefix sum is nothing but, prefix sum is the sum of all the indices till that index. So if I have an array, right, prefix sum at any index I is nothing but, it is the sum of all the elements including the ith and all the elements before the ith. Okay, so if let's say I have an array 1 2 3 4, the prefix sum array would be 1, and then this will store the sum of these two, is 3, then this will store the sum of all of them, which is 6, and then this will store the sum of all of them, which is 10. So this is the prefix sum array for this array. If I have all these numbers stored with me already in this array prefix, now I can represent the sum of any subarray in the form of prefix sums, right? And if I'm saying that this sum is equal to 0, if this sum is equal to 0, can I make any comment about these two values? If this sum is equal to 0, this means that prefix sum of R should definitely be equal to prefix sum of L minus 1, right? Let us visualize this in this diagram and then it will be more clear. So I have these two parts, right? Now I am saying that this blue box represent the prefix sum of R. This is the sum of all these elements from 0 to R. Okay, this yellow box, this represents the sum of all the numbers in the range L to R. Correct. And what about this green box? This green shaded box represents the prefix sum of the index L minus 1, the sum of all these numbers. Can I say that if this is going to be 0, right? If I'm adding the sum of all the index from left to right, and if this part is equal to 0, then whatever sum I get at this point, the exact same sum will also be present after this, because the contribution of this is 0. Does this make sense to everyone? Right? So if I have an array, right, and if I'm just calculating the sum of all the array elements till that index, and then there is a part which is contributing exactly 0 amount, right? So this will give some sum, right? Let's say s, this gives s dash, and then if I add this as well, this gives s double dash, this gives s triple dash, and then this gives something. After I'm here, I will again get s triple dash, because the overall sum of this part is 0. Does this make sense to everyone? Let us take the example as well, and then this will be crystal clear. So I will just copy this thing. So if I just calculate the prefix sum of this array, I will be getting 4, right? 6 minus 3 again is 3, then 4, and then 10. Okay. Now what I was explaining is, since the sum of this part is exactly 0, this part, the contribution of this part in the sum of all these numbers is going to remain 0, right? That is why whatever number I am getting here will also be repeated here, right? So whatever sum I am getting at this point, which is, this point is L minus 1, right? Because I am assuming that this subarray starts from L. So the previous is L minus 1, and this is the R. These two have to be equal. If these two are equal, this means that this subarray, the contribution of this subarray was exactly 0. All the values cancelled out each other, and we are remaining with whatever we had before starting this subarray, right? So how can we now solve this problem? If we calculate the prefix sum of the array, and then if we observe that there is a number repeating in the prefix sum, can I say that the contribution of all the elements between these two numbers is going to be 0, which means that this subarray is adding to 0. Okay, is the idea clear to everyone? Guys, is the idea clear? right? Let's take another example. Let's say I have 4 2 0 1 6. Okay, now if I take the prefix sums, I will be getting 4 6, then again 6, and then 7 and 12. So again I can see that a number is repeating in the prefix sum, which means that whatever comes in between these two, this is, if I said that first number should be L minus 1, this is L minus 1, right? And this number is R. So whatever is from L to R is going to give me a sum equal to 0. L to R here has exactly one element, which is 0. Now one of you asked, what if same number is repeating twice, right? That can also be possible. You will have to understand what is the physical significance of this thing, right? So even in this case, if I just modify this array, here I got 4, then I have 0, then let's say again 0, then I get 2, and then minus 2, and then something, right? Now what will be the prefix sum here? Again 4, 4, 6, again 4, and then 5, right? So this means that all these numbers which are repeating, they all are forming a subarray which is going to give a zero sum. If these two are repeating, this means that we have a sum 0 here. If these two are repeating, this means we have a sum 0 here from this plus 1 to this, right? Because this has to be the L minus 1 index. So even if you have multiple repetition, that points to only one thing, that the subarray between them is giving a zero sum. Okay. Now, how do we solve this problem? So one thing should be clear to everyone, that the first step is that you create the prefix sum array. How can we create the prefix sum array? This is very easy task. You can have P0 equals to A of 0, because the first number is going to be exactly the same. And then for building the rest of the array, you can just keep calculating. You can just keep adding the current value to the previous prefix sum, right? Prefix sum of I is nothing but the previous prefix sum, whatever is the sum till now, plus whatever is the sum of the current element. So now we can run a loop from I equals to 1, I less than n, I plus plus, and then you can say P of I is equals to P of I minus 1 plus A of I. This gives you your complete prefix sum. Now in this prefix sum, you just have to check whether there are two numbers which are repeating or not. Is there any data structure that we know which can solve this problem very optimally? You just have to check whether there are two numbers which are repeating or not. How do you check for a repetition of a number? You can have a hash map, right? Maybe you can have an integer here and a boolean, right? When you get 4, you store true. When you get 6, you store true. When you get another 6, you know that 6 has already occurred. If 6 has already occurred, this means that there is a subarray which is giving a zero sum. If you also want to find what is the length of the subarray, instead of having the boolean, you can try to store the index here. This also becomes integer, and now you can say that 4 occurs at index 0, 6 occurs at index 1, then 6 again occurs at index 2. This means that from this index, this plus 1 to 2, we have got a subarray which is giving us sum equals to 0. Okay, let's take this example which we initially had, this one, right? You can have your key and value. Key is the sum, value is the index in the hash map. You get 4 sum at index 0, then you get 6 sum at index 1, 3 at 2, and then you again get 4 at index 3, right? Now we had discussed, right, that keys are going to be unique. So once you get another same key, you can just check that this key is already present in the hash map and the starting index was 0. This means from 1 to 3, I have an array which is giving sum equals to 0. Okay. Does this make sense to everyone? What is the time complexity of this complete problem, of this complete algorithm? First of all, we have calculated the prefix sum. This costs us order n. While calculating the prefix sum only, you can just also enter in the hash map, right? Here only, what you can do is you can do your map dot put, or first maybe you can check if map dot contains pi. This means that you have found a subarray, you can directly return true, right? Else you can say map dot put pi and comma whatever you are storing, whether it is index or whether it is your true or false, right? And this is going to solve the problem. Overall time complexity here is order n. Okay, so guys, I will now end the session. Please do solve all the problems. Thank you guys.
Hello everyone. So today we have the topic as hashing, and I am Paridhi. I am a software developer at InterviewBit. So today I have selected two questions basically that I'm going to discuss here, and it's basically how important they are from interview point of view. So I have selected them, and so today we are going to do first question is anagram. So let's quickly dive into that. Okay, so today we are going to do our first question, and that problem is anagram. This is a very famous problem. This has been asked in Amazon, Microsoft, Goldman, as you guys can see. Very important from the interview point of view. Let's quickly see what it says. Okay, so given an array of strings, return all groups of strings that are anagrams. Okay, so represent a group by a list of integers representing the index in the original list. Fine, so we are given a group of anagrams, and basically we have to group the same, basically the anagrams together. Okay, so let's see the example for clarification. First of all, what is an anagram? So it's a word, a phrase, or name formed by rearranging the letters of another, such as spar is there, formed from rasp. Okay. So basically, anagram is a word in which two strings can be said as anagrams if they have same characters, right? And the frequency of the characters is also same, but their order is different. Okay, so here as we can see that S is present in spar and S is also present in rasp. Then P is present in spar and P is present in rasp. Likewise, A is present in spar and A is present in rasp, and R is present in spar and R is present in rasp. Fine. And these are the only characters. So these characters are basically jumbled, right? So these are known as anagrams. Now, given the example, we have cat, dog, god, and TCA. Fine. So these are the anagrams, and we have to group the anagrams together, right? Okay, fine. So we have cat, and I can see that 1 and 4 are anagram. That means cat and TC are anagrams. Okay, fine. They have same set of characters and frequency is also same. Makes sense. And dog is there and god is there. They both are anagrams. Fine, makes sense. So they have same basically characters and frequency is also same. Fine. Okay. So what do you think we can do? What is the first thing that comes to your mind? So what I can think of is that these two anagrams, as given in the example over here, the spar and rasp, right? They have same characters and also the frequency is same. So maybe if I like sort them, they should give the same result, right? So if I sort spar, I should get the same result as if I sort rasp, right? Does that make sense? Exactly. So you guys have started to reply and you are on the right track that we can sort them. And after sorting, what is the thing that we are going to get? Let's see. So let me share my screen first of all, the notepad screen. So here we have, so in the example, we have, fine. So let me just copy it down. So we have cat, dog, and god and TCA. So I'm just copying it down on here. So, okay. So if I sort them, this will become ACT, right? And if I sort, so if I sort dog, I will get DGO, right? If I sort God, I will again get BGO. And if I sort TCA, I will, okay, so wait a minute, it just got auto corrected. DGA, sorry, DGO, and this will also be BGO, and this will be ACT, right? So that means here we know that CAT, as in the example, CAT and TCA are anagrams, and when we sort them out, then ACT and ACT we have got the same string, right? Okay, that means anagrams will have the same string, makes sense. And likewise in dog and god, DGO and DGO, they have the same string. Now what can we do to group them up? So as someone of you has have said that we can hash them up correctly. That perfectly makes sense, that basically here the sorted string can act as a, so here the sorted string can act as a the key, right? The key is the sorted string, and the value are going to be the indices of the anagrams. Does that make sense? So here let's actually number them up. So we have one, this is two, this is three, this is four, and we want the indices only, right? So indices are starting from one in this case. So basically the key here for CAT is going to be ACT, and here we are going to have the value will be a we can say a vector where we can store the indices of the anagrams. So ACT is a string and CAT is an anagram for that. So that means we can have in a vector we can have one, and also this TCA is also, if we sort it up, we will get ACT, right? So that means the same string, and so the value is going to be 4 over here, right? So that means we have actually paired up the anagrams, the main task, right? Now the second string is DGO, right? And we can pair the strings that are forming the anagram. So that means 2 and 3. Does that make sense? So, right. We can do it in various ways. We can even hash them up in various ways. We can use frequency arrays as well. So you can do it in any way, right? So let's just code it up. So I think most of you are ready for this. Let's code it up. So here we have the screen, and let's quickly code it out. Right, okay. So basically we will be keeping, first of all, we need a vector of vector for the answer thing, for storing the answer, right? So vector of int, and also we need the map, sorry, we need a map, unordered map. So we'll basically do int, comma, okay, no, sorry, not int, we need string, right? We need string, and we need a vector of int. Let's call it maybe group, right? These are the groups. And now the task is that we have to basically iterate through the vector of strings that is given to us. So let's iterate through it. So I will go from 0 to a dot size, right? And I plus plus. Now, okay. So we will take the first string. Let's take it in. Let's say we will actually have to generate the copy of the string, because we have to sort them up, and also we need the original string, right? So therefore we are maintaining a copy. So let's take it in here, and this will create a copy. Now let's sort the string. So let's sort the copy string. So cpy dot begin, then cpy dot end, right? So we have sorted, and now the task is that we can actually hash it. So that's what we are doing. So let's hash it. So the groups is the map that we have taken, and this is copy, right? So string is copy that we have sorted. Okay, so we have sorted it, and let me see if there are some comments. Okay. So now what shall I do? May I get it in the comments? What shall I write? So basically I can push, if that copy is present, I can push the index value, right? So after sorting this copy string, the string at AI, if after sorting we get a string which is there in the hash, right, which is present in the key, we can actually push I plus 1 to that. It's exactly what we have done in our notepad, right? So we will do it for all the strings, and finally after doing it, we actually have to iterate through the map. Does that make sense? That we have to iterate through the map. So let's do it. Groups is the map. Iterator, let's say, is IT. Now we will simply move through it. So that means IT equal to, that is groups dot begin. Then IT is not equal to groups dot end, and IT plus plus, right? So we have to just take the value, right? So here we have actually maintained an answer variable, answer array, and we have to basically push the entire vector that we have created in our answer, in the main answer, right? So basically we will be pushing back IT, that means the iterator dot second, and here we can simply return the answer array, right? So does this look fine? Please check, everyone. Are you guys coding with me? Yes, so basically for that, we are actually storing the indices only, right? So Nilesh, we are storing the indices only. We actually have taken the string in the copy string, that means the extra string. Then we have actually sorted this copy string, and here we need not maintain the main string basically. We just want the index of that, right? So here we are pushing the index, right? Just as we have seen in the notepad. So that's what we are doing. Let's try it now. Let's see if it passes. Oh, sorry. So this should be pushed back. Great. Let's see if it gets submitted. Cool. So we have done a good job, and we have scored 338 out of 350. Not bad. Okay, so have you guys got it? Have you guys got it? Are you guys with me? Is it clear? Shall we move to the next question, guys? Cool. Do submit it with me, right? Be here with me. Okay, so now let's do the next question of the day. And the next question is, so here I am taking the longest substring without repeating characters. So here is our question. Let's proceed to it. This question has been asked in Amazon, and not only Amazon, I have heard previously, as in recently, that it has been asked in various other companies as well. Can't remember the name right now, but yes, this is a very important question. So let's get to it. Okay, so Ashish says he has a question. In interview, are we allowed to use inbuilt function? Okay, so basically, it's like when you are asked to implement something, which is, let's say you are asked to implement a substring function. In that case, you cannot, use it. Or let's say you are asked to sort the array. So the trivial question is that, so the main question here is that you have asked to sort it. So how can you use a given the inbuilt function, right? In that case, you have to actually perform the sorting with the various algorithms you have. You can't use inbuilt function in that case, right? So here the question is different. You can use the inbuilt function in this case if it's not mentioned. If it's mentioned that you cannot use, then you cannot use, right? So it actually depends. You can actually ask your interviewer about it, that if you can use it or not. Make sense? Cool. Okay, great. So guys, let's move on to the next question. And the next question is longest substring without repeat. Okay. So let's see. So the question says that given a string, find the length of the longest substring without repeating characters. Okay. So here we are given a string. This is the string, let's say, and here it says that ABC is the longest string and the length is 3. That means ABC is the longest such substring in which there are no repeating characters. As you can see that, okay, ABC has unique characters. Okay, so basically we want a substring out of a long string which has only the unique characters, right? Which doesn't have a repeating character basically. In the second example, as you see that we have so many B's over here, and that means here the substring is just a B. that means of length 1, that has a unique character. If we try to extend this up, that means if we try to try to make the length 2, then definitely we will get BB, and length of 2 doesn't have unique characters. Does the question make sense to everyone? Okay. Could you elaborate more? That what would you do? Guys, please at least come up with the brute force approach. I would like to discuss it with you all, that what do you have in your minds? Can you guys think of the brute force approach for this question? Is the question clear to you all? Okay. So guys, please think on this question, okay? And then in a minute, we are going to proceed with the solution. Okay. So Garima says that please explain the question again. Sure, Garima? So here it says that you are given a string, okay? You are given a string and you have to find the length of the longest substring without repeating characters. Now, first of all, do you guys understand what a substring is? So a substring is that when you take, so here if I say that this is a string, right? So what are the substrings of this string? So let me actually show you my screen. Cool. So here is my notepad screen, and let's remove this. So here we are discussing the longest substring without repeating characters. Okay, so let's say I have a string A, B, C, D, and or D, C. Okay, A, B, C, B, D. Now, first of all, what are the substrings of this string? So A is a substring, then AB is a substring, then ABC is a substring, ABC B is a substring, then ABC B is a substring. Okay, then starting from B, we have just B, then BC, then BCB, then we have BCBB, right? Then starting from C, we have C, then CB, then CBD, and starting from B, we have just B, then BD, and then starting from D, we just have D. Does that make sense that these are the substrings of this string? The consecutive characters. Garima, is the question, so the question says that once. So basically you have to find the longest length of the substring that has unique characters. Here such a longest length is just ABC, because if we consider any length which is beyond 3, then that has a repeating character. So if we have let's say ABCB, right? So in this case also we have two repeating characters, as in one repeating character, that is B, right? So B occurs 2 times, which we don't want. So the question says that you have to find the longest substring without repeating characters. Am I clear with the question, guys? Am I clear with the question? Okay, great. Okay, so let me clear this up, right? Okay, so let me actually build your solution, then you will be more clear. Okay, so the brute force approach that comes to my mind is that we can generate all the substrings, right? We can generate all these substrings, and we can check if these substring consists of unique characters or not, right? So how to check if a substring consists of unique characters or not? So basically for that purpose, we can maintain a hash map. What's it? So we can maintain a hash map that will tell us that if some character is already present in our string or not. Does that make sense? That we can use a hash map because it tells us in just order of one time that okay, if some character exists or not, already exists or not, right? So this is the brute force approach. So does anyone know that how many total substrings we can create out of a string? How many total substrings are there? Okay, so total substrings are n into n, wait a minute, n into n plus 1 by 2. Okay, these are the total number of substrings that we can create, and where n is the number of characters in the string. Okay, now so once we generate all the substrings, and then if we check with the help of a hash map that if that particular substring has unique characters or not, then the time complexity for first of all for generating the substring is going to be order of n square. Okay, because total we have n into n plus 1 by 2 number of substring, therefore the time complexity of generating these many substrings is order of n square. Now we also have to check it with the help of a map if it consists of unique characters or not. So for that it's again going to take order of n, because why? Because for maintaining the hash map, it's going to take again order of n. So the total number of time complexity, the total time complexity is going to be order of n. Does that make sense to everyone? Cool. So the time complexity is going to be n cube, but it can be further optimized if, while going through our second loop, we can actually check on that pace only if we are getting the unique characters or not. So what I'm saying is that while maintaining the second for loop, in the second for loop itself, we can check that substring from I till j has unique characters or not. And this we can do in our for loop only, the checking part. We don't have to do it separately for checking the unique string. Okay, so then the time complexity will reduce to order of n square, right? Because here we will be doing it in our second for loop only. We will be checking it in the second for loop only. Does that make sense, guys? Is it clear now that why n square? So n square is because while generating a string, let's say I am at a, so the string is, wait a minute, let's say the string is a, b, c, d, d, right? This is our string. Now I'll keep my I pointer here, and initially the j pointer will also be here. Okay, now we will also maintain a map side by side, and we will put the character in the map that if so, for checking if it's unique or not. Right now in our map a is not there, right? So we will put that, okay, a is not there, that means a is unique, let's put it in our map. So first we will check that if some character exists in the map or not. If it doesn't exist, that means that character is unique. Once we get to know if that character is unique, then we can add that character in the map. Okay, so okay, now we have done it. So we have checked for string a. Now we will move. So now we have ab. So we have in the map we just have a till now, right? Now we will check that if the character at b is in our map or not. If it's not present, that means it's a unique, right? That means it's unique. But once we have checked that if it's unique, we will add it to our map because we have already taken it. So are you guys able to relate that how in the second loop only, that is while moving our j, we are able to check in the map? That's why the complexity is order of n square. Okay, do try to dry run it on your own, right? And then I am sure that you are going to get it. And if you are still confused, then you should definitely try to code that up. Now I would try to, so okay, so here we are now. So the time complexity of the brute force solution is order of n square, right? Or I would say a little optimized solution is order of n square. But here we are generating all the substrings. Do we really need to generate all the substrings? So let me make my point clear from here. So we have A, then AB, then ABC, ABCB, ABCBD, right? So here we are actually generating all the substrings. Here I am trying to make my point clear that we actually don't need it. So I can figure it out. Let's see if you are able to. This is our main substring basically, and here we have all the substrings. Okay. So if you see here in the third also we have to maintain the length as well, right? We have to return the length of the longest string. So when we had 1, the length is equal to 1, right? When we had AB has unique characters, length become 2, right? Then we have ABC, then length become 3, right? Because ABC has unique characters as well. Makes sense, right? Then we have ABCB. That means it doesn't have unique characters. Length is still 3, right? Then again ABCBD is there, and length is equal to 3 again because it doesn't have unique characters, right? So that's how we will keep on going on, and the length will remain 3 entirely. Now the point that I'm trying to make over here is that if you carefully look, then here we have ABC, right? We have ABC, and once we got this fourth B, we come to know that okay, this string can have a length of 3. Then as soon as we are moving to B for length of 4, for checking for length of 4, the strings doesn't have unique characters. Now if you see, then in the second step we are generating ABCBD. Do we really need to do that, guys? Do we really need to check for A, B, C, B, D once we have checked for this? No, right? Why? Because here we have already checked that A, B, C, B is non-unique. Then even if we add D, that doesn't make any sense, because here till this point this is not unique. So in any way, if we try to add more characters, that will still be non-unique, right? So that means this is redundant. So why are we doing which is something which is redundant, right? So we can ignore that. So this is the first point that I tried to make. Now we can actually now the second point that here to be seen is that once we have got this B, right? Once we have got this B, so here from this A, I am sure that my substring having a unique characters starting from A more than of length 3 is not possible, right? Does that make sense? That starting from A, if I have already got the repeating character, and if I had any more character, now it won't create a unique string at all, because here I have a non-unique character. That means starting from A, I have just ABC as a length, right? Now here we have, the point here to be seen is that even from B, if I start, I can get at most 2, I can get the length of 2, right? Where the string length is 2 of the of the unique characters, right? So that means from A, I can get the maximum length of 3. From B, I can get the maximum length of 2. But from starting from C, there is a chance that I get a length of unique characters, a substring of length, a substring of unique characters which is more than 3. Does that make sense? So now here comes the point to do what I can feel is we can do sliding window, right? As suggested by Nilesh in the comments, we can do sliding window. So let's see how can we do that. So let me just remove all of this. We have A, B, C, B, D. Now in my sliding window, I will keep a window. I will start the window from A. Okay. In the sliding window, we have 2 pointers. Okay. One is left pointer and one is right pointer. So I'll keep both the left and right pointer at 0th position, which is A, right? Okay. So A is unique, and that we are going to see it from the, we are going to do it from the map, right? So we are also keeping a map. So let's keep a map. A has a, so we can maintain an index, okay? So we can maintain an index. Let's also put the indices 1, 2, 3, 4, right? We can put an index over here. That means A is at index 0 and A we have already taken. Now let's try to expand the window. Before that, we will also keep a length variable which will keep the track of length. Length right now is A. Now we will move our R. So now the window has become from A to B. B is also not present in the map. Let's make the length 2, right? And add B to the map. Index of B is 1, right? Now let's increase R. So R is at C. So C is not there in our map. Let's include C in the map with the index, right? Also the length has become 3. Now let's move R. Okay, as soon as we move R, we saw that now we don't have any unique characters. So that means length will remain same. And now we will move our left pointer so that we can actually remove the previous occurrence of B, right? We will move our L till the point the occurrence of B becomes 1 only, right? Does that make sense? That we will move it till the point the occurrence of 1 becomes 1. Okay, so let's move our L now. So as I move my L moves to B, right? L moves to B and R is still at 3. Okay, L is at 1 and R is at 3. Now we will, so A has gone out of window. That means L to R is the window. A has gone out of the window. So remove A from map. Okay, we will be removing A from map. Now we will check that still is the element, is the character at R still present in the map? Well, yes, it's still present. It means that it's still the part of the window. And in that case, we will again move our L. So let's move the L, and L comes over here. and B will remain at 3. Now B will be gone, that means here, so we actually remove this B from the window. Let's remove it from here. Now we will check that, okay, is B present now? Is B present in the map? Well, yes, it's not present now, right? It's not present. That means we can include this B in our map now. We can include this B with its current index, which is 3. Okay, which is 3. Now we can start moving our R again. So let's move our R. Now R comes to 4 and B is not present in the map. Length will remain 3 only because L to R, the length is still 3. Let's include D in the map. Now D becomes, so D is at position 4. Okay, and now let's move our R, and now R, there are no more characters, therefore we will simply stop, and whatever will be the length, we will simply return it. So this is how we can process it using sliding window. The time complexity of this approach is going to be just order of n, because we are iterating to each character not more than twice, because one with the left pointer and one with the right pointer, right? So as we are moving our left pointer and as we are moving our right pointer, so we are not coming to any character more than twice. Therefore, the time complexity is going to be 2 into n, which is nothing but order of n, right? We don't consider constants. And the space complexity is order of n again, because here we are using a hash map. Does that make sense? How we have beautifully come across a good, just by building some, observations, we have come to this solution. Does that make sense, guys? Shall we code it? Great. Cool. So let's code it up. Here we are. Now let's quickly do this. Okay. So first of all, I have to maintain an answer which is, let's say, at present int min, right? We want the maximum value, so we will initialize it to int min, or we can initialize it to 0 as well. It doesn't matter, right? Okay, so we can, the left pointer we will keep, which is initialized to 0, and also we will keep a right pointer, right, which is initialized to 0. And also we will keep a length, right, which is again 0. Now we will be iterating through our string. We will be iterating it with the help of right pointer. Right pointer, so let's keep the right pointer in the loop. So let's initialize the right pointer here only to make it more readable for you guys. So right is less than a dot length, then right plus plus. Okay, and we will, okay, so we have to take a map as well, right? So we will take a map, and that will be map will be of char comma int, because we will be maintaining the index. Make sense? We will be maintaining the index with each character. Now, okay, so if the character, at right is present in the, so it's not present in the map, right? So how we will check that? M dot find, right? M dot find is equal to m dot end. That's how we will be checking that if character is not present in the map. So if it's not present, we will simply do what? We will simply do m at a of right is equal to I. Sorry, right. Here we are actually assigning. So here we are doing nothing, but let's say we have A, B, C, B, D, right? So here we are doing nothing. In the map, we will be storing A mapped to 0. That means the index of A. Okay, that's how we will be storing it. Now, after storing it like this, what to do? Let's increment the length, right? Because we have actually found a new character we have included in our map. Let's increment the length. So after incrementing the length, we are done till this point. Now, what if the character is already present, right? So for that, we will use a else block, and in the else block, we will be actually moving a left pointer. We will be moving the left pointer till the point. So let me just write it and then I'll make it clear maybe. Okay, so let me make it clear first. So here, what my point is that I have, let's say, L here and my R is here. Okay, and now A, so let me actually change the map. The map will be For A it's 0, for B it's 1, for C it's 2, and again B comes, right? So I will be moving my L till this point. That means the index of previous B plus 1, because we actually have to remove the first occurrence of B. So we will be moving our L till the index of this B, right, plus 1. So here let me write it. So while left is less than equal to a, sorry, m at a at right, we will be moving our left pointer. And what more do we have to do? Moving our left pointer, and we have to erase the occurrence of whatever is left behind, right? So that means m dot erase a at right. Okay. And also we have to do one more thing. So we have to reset the length. Okay, we will be resetting the length. We have maintained a global variable. That means this is, let's say this is the answer, but as our left and right shifts to this place, that means L comes over here and R comes over here, again the length, so we will also maintain a variable length. So now it will become 2. Okay, it will become 2. That means the current window size, and that is given by what? That is given by right minus left plus 1. Okay, and also we will be updating our answer to max of answer comma length. And finally we will return the answer. Let's see if it works. Are we missing on something? Does this look fine? Okay, so we actually have to do one more thing over here, and that thing is that we actually have to write the new index, right? So here, let's say A was gone, and now the new index of B is equal to 3, right? So that means it's equal to nothing but M at A at right is equal to right, and that's all. Let's test it. I'm really sorry I didn't see that. Let me share it again. Don't worry, I will explain the code. Okay, so you guys want me to just explain it. Cool. It's good that you have understood the logic, and I'm sure that you will all will be able to code it. Let's see. So here I am maintaining the answer, which is initialized to int min. Okay. Then we have a left, that is the left window, and this length is basically the to keep track of the length we have, right? This length is actually from left to right. Okay, now we also have a map that is from map to character to int, that character map to the index. Okay, now we with the help of this right pointer, we will actually be iterating through our string. Okay, and while iterating through the string, we will check that if the character is already present or not. So here we are actually checking if the character is not present. Okay, so the character is not present, so we will actually put the character with the index in the map. Okay, and also we will increment the length. So this is when character is not present, but if character is present, in that case we will be moving the left pointer. Okay, we will be moving the left pointer till the point. So actually I have shown it to you in the editor. I think you have seen it there, right? You have seen it there. So we are actually moving our left pointer till the first occurrence of the repeating character in is gone. Okay, it's gone. So then we will do left plus plus, and we will erase the character that we have left behind. Okay, and then we will do it till the character at right pointer, which we found repeating in the current window. So till the repeating character is no more repeating, we will then add the new index of that character in our map. Make sense? We will add the new index of that character in the map. Does that make sense? So okay, let me complete it, and then I'll get back to your questions. Okay, so here we have the character with its new index, and also now we will reset the length to the length of the current window, right? To the length of the current window, and then we will update our answer. We will update our answer. We will keep on doing this, right? So length will have the size of the current window, and this answer is the global answer that we have. So whichever is maximum, that will come in our answer, and we will return the answer. Okay, we will return the answer. Let me try to submit it. Let's see if it gets submitted. Okay, it failed. Where did it fail? Okay, sorry. We need to erase the left, not right. Okay, and let's see it now. It's still not passing. Let's see if this works. Yes, it worked. So first we have to basically erase, and then we have to do left plus plus, right? Okay, so there was just a little bug. Okay, so is everyone fine with this thing? Okay, so basically, you should use set when you just have to keep track of that particular character only, or I would say that particular data only, as in when you don't have to map anything, right? So here we see that we actually map the character to the index, right? So that's why we used a map, because keeping the index also was necessary to move our left pointer, and therefore we preferred map over set, right? Does that make sense? Execute now that why do we need to keep map over here, why not set? We actually made a streak today, right? So Pavandeep, I would say that yes, maths is important, but competitive programming is more than maths Olympiad, right? So it's more than maths Olympiad, that I would say. But yes, it will definitely help you, right? Because in competitive programming we can see maths a lot. So yes, that's a good question, Pavandeep, that you brought up. So this was it from my side. These were the questions, and I hope that you enjoyed them, right? So see ya, bye bye, take care, stay safe.